So I'm going to take a moment to wrap up our discussion of structured design. At some level, structured design is an archaic way that nobody uses anymore, which isn't entirely true. There's still plenty of places who use some element of structured design out there. So let's talk about some of the advantages of structured design that might be an appropriate solution for you to use. One thing is it really does model very closely to the way most companies write requirements. With the straight, hey, you shall do this, you shall do this. Functional decomposition is a typical way of the way people start thinking about requirements. If they're not using object-oriented modeling to set up their requirements, they're essentially aligning themselves up with this approach of taking the high-level problem, breaking it down into pieces, and then thinking about the steps that those pieces get solved in. And so the flow of data and control through a system is very typically done. I mean, that's why flowcharts continue to be so popular. This is really just a formal version of a flowchart. And so it has some heuristics with it to do a better job. I mean, I'm giving you a very thin look at everything you could understand to do a very strong structured design. And so if you find you're at a company who does a lot of flowcharts, you might want to research structured design a little bit more to give yourself a way to improve the way flowcharts are created. Things like balancing that we talked about that can make you better understand how you put your design together. So there's basically also an advantage in the back end where you're aligning better to the programming language if you're using a structured programming language. If you're using object-oriented programming language, you probably don't align well to this, though I have seen applications in OO languages that were essentially designed as structured. If you're not making good use of objects, you might be doing this. You might be doing structured design and thus representing it better by putting it together with this. And so a nice alignment to code is always an advantage of your design, having a real clear, transparent view between those. Now there's some intangible benefits as well, in that people tend to at least think they understand this nicely. It's been used for a really long time. It's a common skill set amongst people who don't code, who are analysts or whatnot, who don't have a background in coding. So it's something that the notation is well understood. There's a lot of support for it. Not as many case tools do it anymore. That's what you're talking about in the discussion board this week. But there are some who do that. So it's nice. Now, the flip side of that is there are some definite disadvantages. The rules for proper deconstruction into subfunctions are not exactly easy to state. Notice I didn't give you a formula that says if it has this many lines of code or this many features or more than this many inputs, it shall be it doesn't exist. There's many different ways to break it down, and they really get to people's opinion of the way the problem's solved much more than the real world things. One great part about object-oriented systems is you tend to start to capture the real world objects. There's not a lot of debate that if you go to a grocery store, you have a shopping cart, you have a cash register, you have products, you have shelves, things like that. And you can represent those in a virtual way that takes advantage of the process that was done in the real world. Sometimes you can find more clever ways to do it inside the IT world, inside the realm, but generally speaking, we're just automating processes. We could take advantage of that by sticking close to the real world in the world things, and then just changing around the business functions as they come up. That's one disadvantage of structural programming in general, is it's really tough to adjust to new requirements. You basically might have to restructure your whole application to do something slightly differently. So it's not also as easy to deal with concurrent or embedded aspects of solutions, and there's not a lot of details for architectural integrity, whether it's going to hold up to change really well in particular. Now, logistical, it's not really great to get a deeper understanding of the system. You basically are taking the understanding and drilling down. You're not spending a lot of time asking the questions of, well, what else could we be doing? What else do we know? What else is going on out there? Have we captured all the pieces? What sort of reuse opportunities can we find? You're really trying to drill down in a very specific way as opposed to thinking wide range inside of there. And then, as I said, because the case tool support is fading, there's not a lot of new research, not a lot of new energy putting into improving structured design and the way we do that. Strategically then, it's unlikely you're going to be working in a language of this nature, so your language doesn't align, and thus your rules, your heuristics for how you write your code are tougher to find. It's really easy to basically do this whole design and then just say, forget it, let's start over and write the code the way we want to write it. Where in the object-oriented world, it does align much better to the code, and it doesn't make a lot of sense to vary that much. So it's really great for describing algorithms, the structured design is, but data design is entirely a side detail here. And the response to events is that control flow is entirely an afterthought, where that's much more prominent inside of an object-oriented design. So I'm not trying to dissuade you from structured design. It's certainly not where you're likely to spend your career, because most companies are going to be doing C# or C++ or Java or Python or something that is more likely to be object-oriented. But it does provide a good way of understanding how solutions are modeled. You still do this sort of thing in an object-oriented system. You still need to make procedures. You still need to break down steps. You still need to add methods to objects that are going to do work. And so it's not fundamentally different. It's just a different starting point. The endpoint is still code that does these things, and the algorithms, the lines of code, are the same lines of code, even if they're packaged or organized slightly differently. And so the model that we're putting together allows you to capture this in a very structured way that aligns to many good approaches. If you want to try this out, it's good stuff to practice, and I'll be glad to give you feedback on that. So again, DFDs are a good way to do it, especially if you feel most confident with flowcharts. Honestly, I would still encourage you to take some object-oriented approaches. If you've never done OO stuff before, that's really where you're going to find the best jobs, the best options, everything else. So practice that here. But this is a great approach as well. So make your choice. Either way it'll work. Remember, there's a lot of different pieces. Look at the other live chat stuff that's going on to make sure you have the homework right for the session you're in. But otherwise, I look forward to seeing if you do produce data flow diagrams.